Welcome everyone, this is a Legacy School science lesson on physics for year 8 about density. You will need for this lesson your science checkpoint book 3, pages 170 to 175. What is density? Density of a substance is the amount of matter that is present in a certain volume of it. This means how much matter is present within a certain space. As we can see, we have two boxes. They are about the same size and the same shape, but the amount of matter present in each of them is different from the other. One has more matter than the other, so we can assume that one of them is definitely heavier than the other. And this is the density. It is how heavy something is for its weight, or how much matter is present in a certain volume. The basic standard international unit of density is found by dividing the unit of mass by the unit of volume. So it is kilogram per meter cubed. Table 13.1 shows the densities of some solid materials. In school laboratories, when smaller amounts of materials are used, the density of a substance is often calculated using masses measured in grams and volumes in centimeter cubed, giving a density value in grams per centimeter cubed. The density value in units of grams per centimeter cube can be converted to the density value in units of grams per centimeter cube can be converted to a value in kilograms per meter cube by multiplying it with 1,000 by 1,000. For example, ice was found to have density of 0.920 grams per centimeter cube. This can also be expressed as 920 grams per meter cubed. To calculate density. So the equation to calculating density equals mass over volume, or mass divided by volume. If we want to find the density of an object, we need to find the mass of the object and the volume of the object. If we have the mass of the object and the density of the object, we can find the volume by dividing the mass over the density. And if we have the density of the object and the volume of the object, we can find the mass by multiplying the density and the volume. This is table 13.1, which shows the density of some common solid materials. As you can see, different materials have different densities. When we come to measure the density of a regular solid or a rectangular cube, for example, to find the density of it, like we said, we need to find the mass and we need to find the volume. Finding the mass is simple by placing the cube on a balance scale or a weight scale and take the reading of the scale. This is going to give us the reading in grams. To find the volume of a regularly shaped solid, we need to multiply the height times the width times the length. The height being 5 centimeter, the width being 4 centimeter, and the length being the 6 centimeter. So by multiplying the height times the width times the weight, by multiplying the height times the width times the length, this is going to give us the volume of the cube or the volume of the rectangle. So in measuring the density of a rectangular solid block, the mass of the block is found by placing the block on a balance. Check the balance, read 0 first, and reading the scale. The mass in grams is recorded. The volume is found by multiplying the length with and height of the block together and recording the volume in centimeter cube. The density of the material in the block is found by dividing the mass by the volume and expressing the quantities in the unit gram per centimeter cube, then changing it to kilogram per meter cube by multiplying with 1,000. To measure the density of an irregularly shaped object, something that is not like a cube, it does not have a fixed shape. For example, a pebble. The density of an irregularly shaped solid, such as a pebble, can be found in the following way. To find the mass of the pebble, is found by placing it on a top pan balance, as for the solid of a regular shape. The volume is found by pouring water into a measuring cylinder until it is about half full. The volume of the water is read on the scale, and then the pebble is carefully lowered into the water on a thin string. When the pebble is completely immersed in the water, the volume of the water is read again on the scale. The volume of the pebble is found by subtracting the first reading from the second. The density of the pebble is found by dividing the mass of the pebble by its volume. So, the mass, we'll simply place it on a scale and take the reading. For the volume, we will take a measuring cylinder, this tube that you see in front of you, and we will fill it about halfway with water. Then we will place our pebble slowly and carefully into the water and until it's completely immersed. And then we will take the new reading. As you can see, with the irregular shaped object, the reading is now higher. So to get the volume of this pebble, we will subtract the second reading from the first reading. And then we will have the volume. So now we have the mass and the volume. To get the density, we will divide mass over volume. If we have liquid and we want to find out the density of this liquid, what can we do? First, the density of a liquid is found in the following way. A measuring cylinder is put on a balance and its mass is found. A. The liquid is poured into a measuring cylinder and its volume measured. So, this is just like measuring the volume. The mass of the measuring cylinder and the liquid it contains is found by placing it back on the scale. The mass of the liquid is found by subtracting A from B. The density of the liquid is calculated by dividing the mass of the liquid by its volume. So, to measure the density of a liquid, first we will take a measuring scale, the one you see. So first we will take, to find the mass of a liquid, first we will take a measuring cylinder, this one, and we'll place it, an empty measuring cylinder, we will place it on top of a scale, and this is going to give us the reading. So we're going to measure the mass of the measuring cylinder, of the empty measuring cylinder. Then we are going to take our liquid and pour it into our measuring cylinder. When we pour the liquid into the measuring cylinder, it's going to give us a reading. It's going to give us the reading, and this reading is the volume. So now we have the volume of our liquid after placing it on the measuring cylinder. Then we will take the measuring cylinder with the liquid and place it back on the scale. So now we have two measurements of weight, or two measurements of mass. The first measurement is the measuring cylinder without the liquid, and the second measurement is the measuring cylinder with the liquid. So to get the mass of the liquid, we will subtract the second reading, which is the one with the liquid, from the first reading, which is the one without the liquid, and then we now have the mass and the volume. To get the density, we'll divide the mass by the volume and present it in units of gram per centimeter cube, then multiplying it by 1,000 to change it to kilogram per meter cubed. This is a table that shows the density of some liquids. We have different liquids and they all have different densities. Floating and sinking. When a piece of wood is placed in water, the wood floats. This is due to differences in densities of wood and water. From tables 13.1 and 13.2, you can see that wood is less dense than water. When two substances, such as a solid and a liquid, or a liquid and a liquid, are put together, the less dense substance floats above the denser substance. When full fat milk is poured into a container, such as a bottle, the cream, which contains fat and is less dense, then the more watery milk rises to the top. So, in floating, the less dense the object, the more it floats. The higher the density, the more it sinks. So if we have solid and liquid, the less dense object will stay at the top and the higher dense will be in the bottom. And if we have liquid and liquid, same concept. We come to measuring the density of gases. Air is a mixture of gases. Its density can be found in the following way. The mass of a round-bottomed flask with its stopper, pipe, and closed clip is found by placing it on a sensitive top-pan balance. The flask is then attached to a vacuum pump and the air is removed from the flask and the clip is closed. The mass of the evacuated flask, stopper, pipe, and closed clip is found by placing it back on the balance. The mass of the air in the flask is found by subtracting the second reading from the first reading. The volume of the air removed is found by opening the clip under water so that water enters to replace the vacuum. The water is then poured into a measuring cylinder to find its volume. So this is a flask, is a round-bottomed flask with its pipe and clip. This is the clip. So same concept or close to the concept of measuring liquid. First we're going to place it on the scale, but now it contains the gas in it. So the first reading is the one with the gas. So we're going to place it on the scale, take the measurement, then we're going to attach it to a vacuum to suck out all of the air and then place it back on the scale and take the second reading. And now we have the mass. To get the mass, we will subtract the first reading from the second reading. And to get the volume, we will take it, because it's closed, so we will take it and put it under water and then open the clip. When we open the clip, water is going to enter, replacing the empty space, and then this water that entered, we're going to pour it into a measuring cylinder and take the volume. To get the density, we will divide the mass over the volume and show the units in grams per centimeter cube, then multiply by 1,000 to change to kilograms per meter cubed. This is table 13.3 and it shows densities of some gases. For gases, because gases are affected by temperature and pressure, their density is also affected by temperature and pressure. So the density of gases are compared by measuring them at the same temperature and pressure. This is called the standard temperature and pressure. The standard temperature is 0 degrees Celsius. The standard pressure of a gas is the pressure that will support 700 mm of mercury in a vertical tube. When two gases meet, the less dense gas rises above the denser gas. This is the end of our session for today.